Thawing frozen underground electrical conduit can be accomplished through several methods. Firstly, the hot water tracing method involves inserting a hot water hose into the conduit and circulating hot, not boiling, water until the ice melts. Secondly, the electric heat tracing method suggests wrapping an electric heat tracing cable around the outside of the conduit, not inside, and applying power to the cable. Thirdly, the infrared heat method involves using an infrared heat gun or panel to direct heat towards the conduit from a safe distance. Fourthly, the glycol heating method proposes pumping a mixture of water and glycol into the conduit to melt the ice, noting that this method is less effective than hot water tracing but may be safer for longer runs. Addressing the possible causes of a broken conductor, ice expansion is a significant factor. Ice formation in the conduit can exert pressure on the conductors, causing them to break. Thermal expansion and contraction due to temperature fluctuations can cause the conduit and conductors to expand and contract, which can stress the conductors over time. Underground burrowing animals, such as rodents, may have chewed on the conductors. Water leakage, if water enters the conduit, can corrode the conductors and weaken them. Improper installation, such as insufficient cable support or sharp bends during installation, can also damage the conductors. Considering other factors, it's important to determine utility responsibility, as the utility may be responsible for repairing the service line up to the point of delivery, typically at the meter. Once the conduit is thawed, a conduit inspection should be performed to check for any damage or blockages. To prevent future water ingress, improve the seal between the riser pipe and the conduit at the pole. Consider replacement if the conduit is severely damaged or the broken conductor cannot be repaired. It may be necessary to replace the entire underground service line. The initial situation involves a 100 amp underground service running from a pole through 2-inch polyvinyl chloride conduit over a distance of 50 feet to a building. The service is 2 years old and has experienced a lost neutral between the pole and the meter. Attempts to pull the existing wires out to install new ones have been unsuccessful, apparently due to ice in the conduit. The utility's typical practice of overlapping the riser pipe at the pole with a plastic half conduit and using duct seal to keep out water was not followed in this case, potentially allowing water to enter the conduit. Given these circumstances, the following considerations apply. The primary challenge is to thaw the ice within the conduit without damaging the existing conductors or the conduit itself. Several thawing methods can be employed, each with its own advantages and disadvantages. Hot water tracing is often the most effective method. It involves inserting a small diameter hose into the conduit and circulating hot water through it. The hot water melts the ice, allowing it to drain out. It is important to use hot water, not boiling water, to avoid damaging the conduit or conductors. The water should be circulated continuously until the ice is completely melted. Electric heat tracing cable can be wrapped around the outside of the conduit. When energized, the cable generates heat, which thaws the ice. It is crucial to use a heat tracing cable specifically designed for this purpose and to follow the manufacturer's instructions carefully. Avoid overheating the cable, as this could damage the conduit or conductors. An infrared heat gun or panel can be used to direct heat towards the conduit. This method is less efficient than hot water tracing or electric heat tracing, but it can be useful for thawing small sections of conduit or for preventing ice from forming in the first place. Be careful not to overheat the conduit, as this could damage it or the conductors. A mixture of water and glycol can be pumped into the conduit. Glycol lowers the freezing point of water, which helps to melt the ice. This method is less effective than hot water tracing, but it can be useful for longer runs of conduit where it is difficult to circulate hot water. It is important to use a glycol solution that is compatible with the conduit and conductors. Once the conduit has been thawed, it is important to determine the cause of the broken neutral. Several factors could have contributed to the failure. Ice formation within the conduit can exert significant pressure on the conductors, potentially causing them to break. This is especially likely if the conduit is not properly sealed against water ingress. Temperature fluctuations can cause the conduit and conductors to expand and contract, which can stress the conductors over time. If the conduit is buried in an area with significant temperature variations, this can contribute to conductor failure. Rodents or other animals may chew on the conductors, especially if the insulation is damaged or compromised. This is more likely to occur if the conduit is not properly sealed or if it is buried in an area with a high rodent population. Water ingress into the conduit can cause corrosion of the conductors, which can weaken them and eventually lead to failure. This is more likely to occur if the conduit is not properly sealed or if it is damaged. Improper installation practices, such as sharp bends in the conduit or insufficient support for the conductors, can stress the conductors and lead to failure. It is important to ensure that the conduit is properly installed and that the conductors are adequately supported. Given that the installation is only 2 years old and was backfilled properly, some of the potential causes, such as improper installation, are less likely. However, the lack of proper sealing at the riser pipe makes water ingress and subsequent ice formation a strong possibility. Once the cause of the broken neutral has been determined, the appropriate repairs can be made. If the conductors are damaged beyond repair, they will need to be replaced. This may involve pulling new conductors through the existing conduit or, if the conduit is damaged, replacing the entire conduit run. Before pulling new conductors, ensure that the conduit is free of any obstructions or debris. Use a lubricant specifically designed for pulling electrical conductors to reduce friction and prevent damage to the insulation. If the conduit is damaged, it will need to be repaired or replaced. Small cracks or holes can often be repaired with epoxy or other suitable sealant. Larger damage may require replacing a section of the conduit or the entire run. When repairing or replacing conduit, ensure that all connections are properly made and sealed to prevent water ingress. After making the necessary repairs, take steps to prevent future failures. Ensure that the riser pipe is properly sealed to prevent water from entering the conduit. Use a duct seal or other suitable sealant to create a watertight connection between the riser pipe and the conduit. Consider using heat shrink tubing to further protect the connection from water ingress. If the conduit is buried in an area with significant temperature variations, consider using a conduit material that is less susceptible to thermal expansion and contraction. For example, rigid metal conduit expands and contracts less than polyvinyl chloride conduit. If rodents are a problem, consider using a conduit material that is resistant to chewing. For example, rigid metal conduit is much more difficult for rodents to chew through than polyvinyl chloride conduit. Ensure that the conduit is properly supported to prevent sagging or bending. Use conduit clamps or straps to secure the conduit to walls, ceilings, or other structures. When pulling conductors through the conduit, avoid making sharp bends that could stress the conductors. Use a bending tool to create smooth, gradual bends in the conduit. After completing the repairs, thoroughly inspect the entire installation to ensure that it is safe and compliant with all applicable codes and regulations. Pay close attention to grounding and bonding connections to ensure that they are properly made. Test the electrical system to verify that it is functioning correctly. Use a multimeter or other suitable test equipment to check voltages, currents, and resistances. In this specific situation, given the reported issue of water potentially running into the conduit due to the lack of proper overlap and sealing at the riser pipe, addressing this issue is paramount. The utility company should be contacted to rectify the sealing issue at the pole. In the meantime, ensure that the power is disconnected to avoid any electrical hazards. Carefully assess the extent of the ice blockage in the conduit before attempting any thawing methods. Avoid using excessive force when trying to thaw the ice, as this could damage the conduit or conductors. If the ice blockage is severe, it may be necessary to excavate a portion of the conduit to access the ice and thaw it more effectively. Consider using a thermal imaging camera to identify areas of ice buildup in the conduit. This can help to target the thawing efforts more effectively. When using hot water tracing, monitor the temperature of the water to avoid overheating the conduit or conductors. Use a thermometer to measure the water temperature and adjust the flow rate as needed. When using electric heat tracing cable, ensure that the cable is properly grounded to prevent electrical shock. Follow the manufacturer's instructions carefully to avoid overheating the cable. When using an infrared heat gun or panel, maintain a safe distance from the conduit to avoid overheating it. Use a temperature sensor to monitor the temperature of the conduit and adjust the heat output as needed. When using a glycol solution, ensure that the solution is compatible with the conduit and conductors. Check the manufacturer's specifications to verify compatibility. After thawing the conduit, thoroughly inspect the conductors for any signs of damage, such as cracks, abrasions, or corrosion. Replace any damaged conductors immediately. Before restoring power to the circuit, test the insulation resistance of the conductors to ensure that they are properly insulated. Use a megometer to measure the insulation resistance. Consult with a qualified electrician if you are not comfortable performing any of these tasks yourself. Electrical work can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. Always follow all applicable codes and regulations when performing electrical work. Obtain the necessary permits before starting any work. Document all work performed, including the date, time, and description of the work. Keep a record of all materials used, including the manufacturer, model number, and quantity. Take photographs or videos of the work before, during, and after completion. This can be helpful for documenting the work and for troubleshooting any problems that may arise in the future. Remember to always prioritize safety when working with electricity. Wear appropriate personal protective equipment such as gloves, safety glasses, and a hard hat. Work in a well-lit area. Avoid working in wet or damp conditions. Disconnect the power before working on any electrical equipment. Test the circuit to ensure that it is energized before starting work. Use insulated tools. Never work alone. Have someone nearby who can assist you in case of an emergency. Know the location of the nearest electrical panel and how to shut off the power. Know the location of the nearest fire extinguisher and how to use it. If you are not sure how to do something, ask for help. There are many resources available to help you learn about electrical safety and best practices. These resources include online tutorials, books, and training courses. By following these safety tips, you can help to prevent accidents and injuries when working with electricity.